Energy by a windmill. The blades of a windmill sweep out a circle of area A. If the wind blows at a velocity perpendicular to the circle, what is the mass of the air passing through it in a time t? What is the kinetic energy of the air? Assume that the windmill converts 25% of the wind's energy into electrical energy, and you are given the area and the speed and also the density of air. What is the electrical power produced? Okay, so we know windmill converts the wind energy into electrical energy. One of the use of the windmill is to convert the wind energy into electrical energy, and this is the area swept by the blades of the windmill. Suppose there are 3 blades, and when they will be moving in a circular path, this will be the area swept by the blades of the windmill. Now we have seen in fluid mechanics, we have seen in the fundamental of fluid mechanics, if there is an area A and the wind or any fluid, liquid or gas, is flowing perpendicular to it with a velocity v and the density at the location of the surface is rho, then the mass flux means the mass flowing per unit time. It is equal to rho a v. That is the formula for the mass flux which we have derived in fluid mechanics, right? This is the mass flux of any fluid, liquid or gas, crossing a surface area A, where the density of the fluid is rho. Okay, now say in the present problem, the windmill, the blades of the windmill is intercepting a circular area A, out of which the wind is flowing perpendicular. So I am making the velocity of the wind as a dot because the vector will be perpendicular to the plane of the board. So this is the velocity of the wind, and the density of the wind is rho. So can you tell me what will be the, if you see the side view, so you will see the surface side like this, and wind has a velocity vector v, this is the velocity of the wind, and the surface area is A, that is the area of the circle, and the density is rho. So the mass of the wind coming per unit time, that is the mass flux. We are importing this knowledge of fluid mechanics. This will be rho AV, correct? Let it be equation number 1. This is the mass crossing the circular area in unit time. Got it? Now what is the mass of air passing through it in a time t? Now you have to find what will be the mass of air passing through the circular area in a time t. Okay, now that is very straightforward. This is giving you the mass crossing the area in unit time. So we can write the mass passing the area in time t. Okay, the mass passing the area in time t. So what do you think this mass will be? So we can write m is equal to dm will come to be, if you are making dm as a subject, rho a v dt, and if you need to find m, so it will be simply of integral of dm from t0 to t. So you'll get rho is a constant, a is a constant, okay, v is a constant, so you'll get dt from 0 to t. So your answer will come to be rho a vt. So this is the mass of the wind coming out of the circular area in a time t. That is answer to part A. Now in part B we have to find what will be the kinetic energy of the wind or air. So in part B simply you have to find the kinetic energy of this much wind. So the kinetic energy, you can apply the formula half mv square. So you'll get half rho a vt, that is the mass in time t, v square. So you'll get half rho a v cube t. Okay, so this is the expression for the kinetic energy of the air or wind coming out in a time t. Let it be equation number 2. Okay, now what about third part? Now part C says, assume that the windmill converts 25% of the wind's energy into the electrical energy, and you are given the numerical value of A, V, and of course the density of air. So wind is converting 25% of the wind's energy into electrical energy. What is the electrical power produced? So we have to find what will be the electrical power produced. So see, the wind is converting the energy of the wind, which is in the form of kinetic energy. Okay, so we can write energy of wind is its kinetic energy, half rho A V cube T, correct? So how much electrical energy will be produced? Electrical energy produced in time T is 25% of this thing, 25% of kinetic energy. So it will be 25 by 100 of 1 by 2 rho A V cube T. So I'll get 1 by 8 rho A V cube T. So this will be the production, this will be the amount of electrical energy produced in a time, how much? T. This is the amount of electrical energy produced in a time T, correct? Now we are interested in finding the rate of the production of energy, that is the power of electrical energy. So we know the power is the energy produced divided by the time interval. So we'll get 1 by 8 rho A V cube T divided by T. Now T will get cancelled away and your answer will come to be 1 by 8 rho A V cube. This is your answer to part C of the problem. So this is how we did this particular problem, okay? Energy by the windmill.